Hello, I'm Adrian.
This is Jomily.
And I'm Jocelyn, and we will be traveling through time to concisely know and witness the origins and greatest development of mathematics that flourished during the old times.
That's right. As learners and mathematics enthusiasts of the contemporary time, it is important to know how mathematics evolved in history and the stories behind the theories, postulates, and mathematical principles that we use today.
So what are we waiting for? Suit yourselves as we are about to have a glimpse of four of the most remarkable civilizations that honed the development of mathematics. Let's go!
Ancient Greek civilization is believed to be the most impressive, most influential in Western culture and in founding mathematics. The Greek Empire was accepted to date around 800 BC. It was concentrated on the Aegean Sea, between the modern-day Greece and Turkey, together with hundreds of loosely scattered city-states. Mathematics is believed to have been used during the Archaic period on the age of Thales of Miletus. The sources of information about the history of mathematics in Greece are less reliable. Most of the mathematical works of ancient Greeks that are still being used today are the ideas and concepts anchored in geometry, and it can be obviously seen from the temples and structures built during that time that comprises geometric shapes and patterns. Euclid. He is referred to as the father of geometry, and his work, Elements, was used to teach history of mathematics. Next is Pythagoras, another Greek mathematician who worked with abstract geometric objects and numbers. He is well known for his Pythagorean theorem. Another is Archimedes. He is known as the greatest mathematician of antiquity and the father of mathematics. And then we have Aristotle. He has a vast knowledge in different fields of study, in mathematics, geology, physics, metaphysics, biology, medicine, and psychology. The earliest numerical system used by the Greeks is called the Attic system. The symbols were used repeatedly to represent a number, and it is also non-positional. They use symbols for 1, 5, 10, 50, 100, and so on. But later on, during the Alexandrian age, the Attic system was replaced by the Ionic or Greek system. It was non-positional, but it was alphabetical. Example, 866 will be represented as. Larger numbers are represented by putting apostrophe before a unit. For example, 3,287 will be represented as. This is the end of our ancient Greek journey. Now let's go on to another civilization that also honed the development of mathematics.
Islamic mathematics. The Islamic Empire established across Persia, the Middle East, Central Asia, North Africa, and parts of India from the 18th century onwards made significant contribution towards mathematics. They were able to draw on and fuse together the mathematical developments of both Greece and India. One consequence of the Islamic prohibition on depicting the human form was the extensive use of complex geometric patterns to decorate their buildings. Right? Muslims discovered all the different forms of symmetric that can be depicted on a two-dimensional surface. The Quran itself encouraged the accumulation of knowledge, and a golden age of Islamic science and mathematics flourished throughout the medieval period from the 19th to 15th centuries. The House of Wisdom was set up in Baghdad around 810, and work started almost immediately of translating the major Greek and Indian mathematical and astronomy works into Arabic. The outstanding Persian mathematician Muhammad al-Khwarizmi was an early director of the House of Wisdom in the 19th century, and one of the greatest of early Muslim mathematicians. Perhaps, al-Khwarizmi's most important contribution to the mathematics was his strong advocacy of the Hindu numerical system, which he recognized as having the power and efficiency needed to revolutionize Islamic mathematics, and which was soon adopted by the entire Islamic world and later by Europe as well. Al-Khwarizmi's other important contribution was algebra, and he introduced the fundamental algebraic methods of reduction and balancing, and provided an exhaustive account of solving polynomial equations up to the second degree. In this way, he helped create the powerful abstract mathematical language still used across the world today, and allow a much more general way of analyzing problems than just the specific problems previously considered by the Indians and Chinese. The 10th century Persian mathematician Muhammad al-Karachi worked to extend algebra still further, freeing it from its geometrical heritage, and introduced the theory of algebraic calculus. Binomial theorem. Among other things, al-Karachi used the mathematical induction to prove the binomial theorem. A binomial is a simple type of algebraic expression which has just two terms which are operated on one only by addition, subtraction, multiplication, and positive whole numbers exponent such as x plus y squared. The coefficient needed when a binomial is expanded from a symmetrical triangle, usually referred to a Pascal's triangle, after the 7th century French mathematician Blaise Pascal, although many other mathematicians had studied it centuries before him in India, Persia, China, and Italy, including Al-Karaji. Some 100 years after Al-Karaji, Omar Khayyam, perhaps better known as a poet and the writer of the Rubaiyat, but an important mathematician and astronomer in his own right, generalized Indian methods for extracting square and cube root to include 4th, 5th, and higher roots in the early 12th century. Carried out a systematic analysis of cubic problems, revealing there were actually several different sorts of cubic equations. Although he did in fact succeed in solving cubic equations, and although he is usually credited with identifying the foundations of algebraic geometry, he was held back from the further advance by his inability to separate the algebra from the geometry, and the purely algebraic method for the solution of cubic equations had to wait another 500 years in the Italian mathematician Del Ferro and Tartaglia. The 13th century Persian astronomer, scientist, and mathematician Nasir al-Din al-Tusi was perhaps the first to treat trigonometry as a separate mathematical discipline distinct from astronomy. Building on earlier work by Greek mathematicians such as Menelaus of Alexandria and Indian work on the sine function, he gave the first extensive exposition of spherical trigonometry, including listing the 6 distinct cases of a triangle and a spherical trigonometry. One of his major mathematical contributions was the formulation of the famous law of sines for the plane triangles. A over sine A equals B over sine B equals C over sine C. Although the sine law of 4 spherical triangles had been discovered earlier by the 10th century Persian Abul Wafa Busjani and Abu Nasar Mansur.
So ngayon, I will discuss some about Hindu mathematics. History of Hindu mathematics. Indian mathematics emerged in the Indian subcontinent from 1200 BC until the end of 18th century. In India, mathematics was first developed as Vedanga or a limb of the Vedas, an art subserving a religious purpose such as the construction of the sacrificial altars. What is India's greatest contribution to mathematics? As well as giving us the concept of zero, Indian mathematicians made seminal contributions to the study of trigonometry, algebra, arithmetic, and negative numbers, among other areas. Some Indian mathematicians and their contributions. One of the famous mathematicians in India is Aryabhata, also known as the father of mathematics in India. The most significant contribution of Brahmagupta was the introduction of zero to the mathematics, which stood for nothing. Srinivasa Ramanujan is one of the famous Indian mathematicians. His important contributions to the field include Hardy Ramanujan Littlewood circle method of number theory. Indo-Arabic numeral system is a positional decimal numeral system and is the most common system for the symbolic representation of the number in the world, and it was invented between the 1st and 4th centuries by Indian mathematicians.
And finally, let us now go to the early Chinese to know the developments of mathematics. China is one of the world's oldest and successful civilization. The Yangtze River is the cradle of Chinese civilization, which is located in the southern part of China. Around 220 BC, during the Qing dynasty, the Chinese built the Great Wall of China, and this reflected their engineering skills and mathematical calculation. Most of Chinese mathematics are written on bamboos or paper that perished through time. The most remarkable writing that survived is the Zhujiang Zhuangzi from 200 BC that contains calculation of areas and volumes, evaluation of square and cube roots, and the systematic solution of simultaneous equations. Several Chinese mathematicians engaged themselves on establishing the approximate value for pi. Some of them are Zhang Heng, the inventor of seismograph, who proposed that the estimated value per pi is the square root of 10, which is about 3.16. Another is Lu Wei, who uses Archimedes' method for establishing pi by approximating circle through polygon, proposed the value of pi to be. And last is during the 5th century, when Zhu Chongzhi and his son used polygons having 24,576, had arrived at a result of The Chinese has two systems for enumeration. First is the oracle bone script and modern numerals, wherein numbers from 1 to 10 were recorded with distinct symbols, together with extra symbols for 20, 100, 1000, and 10,000. And another is rod numerals. In here, numbers are denoted by patterns called songs and hangs that represent powers of 10. Songs denoted units 100s, 10,000s, and so on, while hangs denoted units 10s, 1000s, 100,000s, and so on.
This has been the end of our travels and time journey. We hope you guys learned some mathematical insights. And always remember that the past upholds the present and the future.